Hello, everyone. Welcome to our session. My name is Carmen Puccio. I'm a senior manager here at AWS within the AWS Partner Program. I'm joined with Rob John. Just quick brief intro on myself, and I'll let Rob go. I've been with AWS for almost 6 years now. I'm a senior manager within the AWS Partner Program for a group of partner solutions architects that work with our technology partners such as Dynatrace and our consulting partners as well. Prior to this role, I was the principal solutions architect for the container team within AWS, and before that, I was within the AWS Mass Migration team. Super excited that you folks chose to spend your lunchtime with us, and hopefully you learned something exciting today. Rob?
That's right. Yeah, so thank you all for coming. Yes, Rob Jan from Dynatrace in the partner team. Been with Dynatrace about 3 years, so I've worked actually closely with Carmen on a lot of our ready programs from EKS and Fargate and a lot of containerized programs. So we're excited to talk about Lambda today. Prior to here, I was with consulting firms working a lot with performance engineering and test kind of at large enterprises.
Yeah, cool. So we'll do Q&A after. Just meet us in the hallway. If you have any questions, just save them to the end. Hopefully we address everything in the session, but if not, we're happy to talk to you after the show. But with that said, I'm just going to get started, all right? And just make sure I get the slides going here. There we go. All right, so the first thing I want to say here is, and thanks to Dynatrace for being able to pull these stats, right? So serverless adoption is accelerating. We all know it. It doesn't matter if you're a startup, mid-market, enterprise. I talk to customers and partners all the time. The serverless space is a rapidly growing space. So again, like it's great that you get that breakdown that it's basically across all languages. All the popular languages are up there now. The thing that's important to recognize here is it's not just Lambda. I like to make this clear, distinguish this fact. You see a thing about containers here. And it's interesting that we consider services like ECS Fargate and EKS Fargate serverless platforms, right? So whether it be Lambda, whether it be popular services like API Gateway or step functions, containers are also in that mix. And amongst that mix, we're seeing our customers basically deploy across a wide variety of use cases and using all the popular languages to support it. And then when it comes to benefits, right, it's all of the benefits that you've heard about before, but the one thing, you kind of combine these together, and it's when you think about like reducing operational cost and productivity gains, I always talk about something called the acceleration flywheel. You've probably heard me talk about it in many of my talks, and many of my colleagues talk about it. And if you think about it, right, you really want to get your culture and your teams to a point, where they're basically innovating at a rapid pace. And if you think about how they're actually deploying applications, how they're actually getting those applications out into production, they're able to do essentially gain productivity around deep metrics and being able to pull all of the associated metrics around scaling events and operational incidents, whatever it may be, and being able to feed that back into your dev teams and your operational teams so you can further iterate. And we always talk about like it's okay to fail as you go through your experiments as long as you have that flywheel set up and a mechanism or a tool that gives you that insight. That's the important thing to think about. And that doesn't necessarily only limit itself to serverless. That's across the board. We talk about that when in any situation where we're talking about application modernization. But in the serverless space, obviously folks are trying to reduce that operational cost. They're trying to increase that developer productivity. And from the AWS side, we're trying to make it as easy as possible, right? We want our developers to be able to worry about the application and not the infrastructure itself. And we're trying to make it as easy as possible to get started. So, you look in the Lambda space and you look in the serverless space, we have frameworks like the serverless framework. You may have heard it referred to as SAM. And again, in the container space, because certain container platforms like ECS Fargate and EKS Fargate are considered serverless, we have things like AWS Copilot to get you started. Again, getting you started quickly so you can focus on the application. And then when it comes to use cases, it's across the board, right? It doesn't matter if it's machine learning or IoT. Like we're basically saying, again, whether you're startup, enterprise, mid-market, whether you're building web applications or you're doing batch processing or you're doing event-driven workflows, like serverless use cases apply. It's really figuring out the tools and the techniques and the proper way to monitor them. That's the thing to think that's essentially really, really important when you're thinking about the use cases for serverless. But again, to double down on that point around Lambda and the fact that most people associate Lambda and serverless as essentially the only serverless topic. It's true to an extent because sure, Lambda is a serverless offering that we have, but there's many more, right? So step functions, API Gateway, Event Bridge, right? Those are all applicable as well. But I want to take a step back actually and talk about the importance of this diagram. And if I think about the way that, when I was on the mass migration team, the way that customers modernize their application, we call it a two-step approach, right? So typically they're working within their data centers and they're figuring out, okay, I have all of these complex workloads. How do I move my applications over to AWS? And how do I do it strategically? We talk about application dependencies because it's never just one app in your stack, it's multiple applications talking to each other. And you have to figure out essentially your migration waves, right? Once you move those applications over, there's always that point in time where there might be connectivity back to your data center. You're not going to pick up 15,000 servers, for example, and move them all at one time. You're going to do it in pieces, and you're going to be very strategic about it. But in that two-step approach of modernizing an application after you've moved it, after you know it's running successfully, you start to introduce all of these next-generational technologies into your stack. So whether it be Lambda or whether you're taking advantage of Kubernetes or any of the things that you see here or don't see here, right? The importance is you need that ability to trace all the way back through your workloads and understand where your pain points are. Because the more and more you introduce various different servers, the more dynamic your environment starts to scale, the more complex it becomes in terms of trying to figure out where your pain points are. And this is why you really, really need an operational tool to help you pinpoint exactly what's going on, which gets us into the observability challenges, right? So all of these should be relatively common, right? The folks in the room, you know, if you've been in war rooms before, the one thing you want to avoid is getting into those situations where it's finger pointing, right? You have an end user that can't connect, something's wrong inside of your stack. It doesn't matter if it's a monolithic stack, it doesn't matter if you're in this cloud-native microservices stack. You want to be able to basically figure out in a single pane of glass what's going on anywhere in your environment. And I want to double down on that hybrid story right there as well. If you think about like that mass migration scenario where you're talking back to your data center, completely applicable. But there's also other use cases. If you look, AWS is doing a tremendous job in stretching into the hybrid space. Look at the releases that we've done recently with EKS Anywhere, where the ability to run Kubernetes on-prem, ECS Anywhere for the Elastic Container Service on-prem, Outposts, wavelength, local zones for edge. It's a very common use case where customers want to essentially keep certain components of their workload close to their user base for whatever reasons, right? And then other parts of their application are sitting up in the cloud. But the importance is as that portfolio essentially stretches, you need to understand what's going on. And if you don't have a tool or a single pane of glass to give you that level of transparency, you get into that finger pointing exercise, and that's what we want to avoid. The other part here, as you grow and as you start to adopt things like Lambda, and again, this is a Lambda-specific talk, so I'll call it out, but it's far and wide, right? In the Lambda world, you could have millions of invocations happening through a scaling event, for example, or it's just part of your normal workload. And as you're basically collecting all of that data, if you think about all of the telemetry that's coming out, and if you think about essentially how are you going to go through, how are you going to diagnose, how are you going to find those pain points, that's a really tough problem. Right? Where are you going to store all of that information? And to my point before, if you are in that hybrid situation, do you want silos? Like, do I want to go log into essentially one platform to figure out what's going on in my hybrid environment versus what's going on over in this region versus what's going on over at edge? You need that single pane of glass to figure out what's going on. And then lastly, you get to the point where, again, too many tools is probably not the best path. You want that one thing that can help you do two things, right? You want to be able to find and essentially figure out the easy way to tune your performance, right? Again, when it comes to something like Lambda, you're paying as you go in terms of usage, right? So it's a pay-as-you-go billing model. And essentially, if you can get to a point where you're very performant with your application, you're actually going to save money. So the whole point here is to have something that can give you that really, really granular, down to essentially like this particular API is talking to this particular endpoint, and you can figure out what the transactional, like at the millisecond level, what's actually happening, and is that a place where I need to focus within my code to fine-tune it to subsequently save costs and make my app more performant. At the same time, there's another example, right? Maybe you're thinking about introducing a groundbreaking change into your application. We recently released AWS Graviton 2 support for Lambda, where you can build ARM-based workloads. And the whole point of that is to make your applications more performant and also to actually increase or give you cost benefits, right? They talk about a 20% cost benefit by adopting Graviton. And if you're going to introduce something like that into your environment, the one thing that you want to do is you want to have a good before state and understand exactly where I'm at, and then have a way to compare. And again, a singular tool like Dynatrace is going to give you that visibility that you need to make that data-driven decision. And that's super important. So with that said, I'm going to let Rob go into the benefits of Dynatrace, and then we'll talk about some of the cool stuff that we've built over the last year between the two teams. Rob?
Yeah, that's great. So, and I'm going to do some, I'm going to get the volume a little bit, but I'm going to do also some demos so you can see sort of some color of Dynatrace in action, monitoring the AWS services. But let me just kind of walk through, with those challenges that Carmen rattled off, what we need to solve that problem. This is where Dynatrace comes in to help with this thing. So there's a need to automatically understand what's happening in your environment. As Carmen said, new technologies are coming up, new architectures are taking place, and it's important that we understand and be able to monitor those things real time as they're taking place. And also, what we find is this, and you'll see when we show some of the demos here, there's just a lot of interdependencies, there's a lot of telemetry data, and it's just too much for any human to understand. So this is where, the heart of Dynatrace is this telemetry data, is a data model that gets into an AI assistance layer that's analyzing what's happening, baselining what's normal, understanding the dependencies, and ultimately getting to the root cause of problems through a deterministic engine. And as Carmen said, we're trying to have a single pane of glass, not have a bunch of different tools, but have this end-to-end visibility from the database to the front end, from your on-prem to the cloud, and in some cases, multi-cloud. So there's a need for supporting full visibility for all of those scenarios. And then, we talk about Lambda. We're going to get into this some specifically, but there's insights that developers need to get insights to tune and optimize Graviton. Like you just said, baselining and benchmarking, those types of improvements is also kind of key. And so when we talk about Lambda specifically, and we'll get a demo into this, so what AWS is bringing in Lambda natively, we have two different methods which we're going to demo today. One is just directly through the CloudWatch metric ingestion, so any sort of metric published from CloudWatch, from any of the services, including Lambda, will be displayed with all that time series metrics, and that is feeding ultimately into our AI engine, which is also determining what's happening and giving you context into it as a whole. So here we have an end-to-end visibility of data coming in from your existing infrastructure elements, new services, and then through a distributed tracing technology. So the Dynatrace is really distributed tracing, but also embracing open telemetry and driving that standard so that we can get this end-to-end flow that's going to span from your legacy things to on-prem things to all the new serverless technologies and container technologies. And then we really want to link that into the end user experience because that's ultimately what we're measuring and trying to make sure is not impacted. And all of this, as you see, is through the Dynatrace platform. So just as a short brief on the Dynatrace platform itself, we are a platform, we are a partner. We're working with very large enterprises. We're a publicly traded company, now over 3,500 employees. And we have a series of different capabilities ranging from the end user experience, infrastructure monitoring, now cloud automation, digital experience. And it's really supporting on-prem, open standard technologies, as well as all the cloud ingest. So with that said, we'll get into just a quick demo. We're actually going to have a series of these, so I'm going to kind of talk through as they go. So this first one is going to walk through what does the Dynatrace product look like, and then we'll see some of the serverless functions in action. So if you remember that picture just earlier in the slide deck, this is kind of the Dynatrace platform. So this is a view of a real environment. Dynatrace has a vertical stack from hosts to services to processes and applications. So what we're looking at here is a view of all the service-to-service dependency mappings that were automatically detected through our technology. And if we look, kind of zoom in here, you can see right in the middle of all this is maybe a little Lambda function. So if I pick on that little Lambda function, so just to add some color to that diagram, this is where there's a context. So you may have an all Lambda environment, but oftentimes you're slowly replacing functionality with serverless container technologies or individual serverless Lambda functions. So that's kind of just gives you a little picture of that. And then here in Dynatrace, we have account mapping. So this is sort of a screen. I have two accounts in this environment. So I'm going to click on one of my AWS accounts here. And then what we'll see is this is a view of a built-in view of letting us see all the CloudWatch services that are coming in. I filtered here on the Lambda function. So here's a listing in this particular environment. So if it's just CloudWatch metrics, as I showed kind of in the screenshot, you're going to have all that time series data. But then with the ARM extension and the Lambda layer, which we're going to demo how that's all set up, then we get deeper insights happening. So we have the telemetry data, we have all the tags that may have been set up to give us context for that particular service. And then in the Dynatrace platform, this service gets represented in this kind of view. So any service that would be a Lambda or a container would be represented in this manner. And what we're really looking here is at these dependencies. That's the real key. So in this particular example, we can see one service on the left is invoking this service. And the way we can kind of see this call flow, which I'm going to show here in a second, is we can kind of go who calls this service and then who calls me. So in this case, we're going to click on the backtrace. So I'm kind of starting, if you will, from the Lambda, and kind of it automatically works its way back through the tracing stack. In this case, we can see the Lambda function is called by an app server. This app server is actually called by a couple of different front-end applications. So right here, we're getting a great visibility of how this thing is being called. You can see some other metric here about the volume of requests, some of the response times. And what I'm going to do here is click into one of these, and so that we can get a little further view. And because what's happening is Dynatrace is capturing every individual request as it comes in. Dynatrace calls these pure paths. So on this page, we can kind of get a time series metric of each one of these requests. And on this table on the bottom, these are individual invocations of a Lambda function. And so what we're able to do is kind of get a lot of context where it came from, information about the headers, the sources, things like this. And if we drill a little bit further, we can get into the timing details as well as the code level visibility of what may be happening. So this is kind of a simple function that's really just calling an RDS database here, but we're seeing all the header information. If there was OpenTelemetry spans, we would see that. So in this one, we can see most of the time is being spent, and this is in milliseconds, making an RDS call. So we'll see in the next demo a little more, one that does a little bit more than this, but just kind of lets you see kind of that relationship of the service as a whole, individual invocations, a little bit of the code level visibility of what's happening. And then here, if we went the other way around, we kind of go top down. So here we can see this function forecast as it was doing its call trace. We can also see the full trace coming from the web server down into the invocation. And we get that summary information as well as the timing information. So as someone trying to triage a problem or understand things, you may not always go into an individual request, but this lets you see what's happening. And to kind of do that analysis is what we have some tools because we have all the data. So built into Dynatrace is the ability to take any metric that's coming in and do this kind of analysis, which through facilities like this one here. So what I'm going to do is pick a response time metric. And this is going to pull up that time series data. And this is that cold start that I was kind of mentioning earlier in the talk. So we're going to filter here by the cold start, and we can tell whether this is whether this particular invocation was related to a cold start. And so you can see sort of that impact to the response time. So some of these are now 1 second, 1.5 seconds. So this is some data to determine prioritization really, whether this one needs to be tuned a bit more, or you can see what the normal state is. So this kind of analysis, is maybe what can be, done on demand. All these can be put on a dashboard. You can do things like that. Any metrics can drive alerting, obviously, things like that as well. So I think that's the end of this particular demo. And then I'm going to turn over back to Carmen for a minute to talk about some use cases, and then we'll do another demo.
Yeah, thank you. Okay, so it was back in October of 2020 that the AWS Lambda team announced essentially a new feature for Lambda called Lambda Extensions. And we recently GA'd it in May of 2021, and Dynatrace was a launch partner, so super excited to have you folks on board. But essentially, if you think about what the challenge traditionally was, and I'll go into this in detail after the next demo, customers were looking for an easy way to integrate with the Lambda environment, specifically around things like observability and topics around security, right? And it was really kind of gated in terms of how those particular partners and or a customer could integrate with Lambda. So we decided to make it more flexible and basically give customers and partners a new entry point. And what's really cool about it, and I'll go into this in depth, is we've now actually extended it where you can kind of control the execution environment in itself, and I have a good diagram on this, but you can actually do things now before your specific app-specific code fires up, during and or after, right? And that's something that was essentially unheard of. And it's not just partners that are building on top of this feature. We have AWS services that are basically building extensions to make it easier for you as a customer and a partner to basically integrate with Lambda and use it inside of your workloads. So a really good example is AWS App Config. And App Config is part of the systems manager team, and it allows you to store configuration values and basically deploy those values out to your production environments. They created a Lambda extension that allows you to do, as you can see there, fetching configuration settings and secrets for your workloads. And if you think about the way that that was traditionally done, right, most customers would use something like maybe a secrets manager. It's a completely viable, way to store your secrets, and it's a secure way to store your secrets. Or potentially, maybe they're putting things inside of an environment variable. Secrets like passwords, probably not the smartest thing. You should be using an externalized thing. But maybe there's also variables about your application that you want to store as an environment variable. For instance, like log level, right? Maybe you want to have things like, informational, verbose, whatever it may be, error. You want to be able to fine tune those. And in the past, you would drive those in as an environment variable, and if you ever wanted to change them, you would have to redeploy your Lambda function, right, which is a whole new deploy to your production environments, and you might actually take a hit, and you have to figure out, like, how am I going to basically account for the traffic shifting, am I doing, like, aliases and whatnot, and why not make that easier? So the App Config team basically built a Lambda extension that allows you to store a configuration, and then that configuration sits as an extension that the Lambda runtime environment can interact with. So when I talk about, like, you can do things before, after, and during, the before in this case is actually pulling that secret and presenting it to the Lambda function environment, to the runtime API, for your application code to interact with. And if you need to change it, for instance, like I was talking about, maybe you want to set something in debug because you're trying to troubleshoot, all you would have to do is change that variable inside of app config, and then as you deploy it out of that environment, it'll actually go right to your Lambda execution environment for your current version. It's not going to deploy a brand new version on top of it. It gives you the ability to basically say, okay, I want to interact with something that is present and that's already warmed up, and not suffer a cold start penalty or have to worry about doing a net new deploy. And it's a really powerful feature if you think about it, and it's exciting to see, our own internal services essentially eat your own dog food in terms of giving customers, flexibility around this net new feature. So again, use cases are far and wide, whether it's partner tools, open source, or you as a customer want to build your own extension. And we'll go into detail about the Dynatrace extension in a second, and then I'll also show you how it works under the covers. So
yeah. That's right. Yeah. So, and what you saw earlier, with the tracing and some of the metrics was all powered as a result of the extension layer, which we're going to show how that gets set up. But what we want to do next in terms of our demo is really highlight a feature of Dynatrace, which is that AI engine I mentioned before. So once we're bringing in the data in, and we can see the tracing, we can have the AI engine detect problems, and that's kind of what this next demo is. So as the application, it's going to be a single-page app, which we call Dynado, which is like a to-do list. So we already have go to reInvent is our to-do list item, but so the architecture is the single-page app. It's a node running in containers, and we have a series of Lambda functions that do like the get, update, request of this particular function. And then we have Dynatrace, extension layer for each of these things, both on the container so we can see the end-to-end traces. And then what we're doing over on the left, I think there's a little arrow, which I'm simulating load. So in order for Dynatrace to monitor things, I'm actually using a JMeter script to send traffic. And you'll see as we do the demo, I'll sort of have good load that will have a healthy state, and then we're going to send some requests in that cause some problems that Dynatrace will pick up. So here I am in the Dynatrace services view. So each of those Lambda functions that are being instrumented show up as a service list. And then this is a view that you just saw a second ago, but for this particular function. So we can see the time series data and kind of go into the view of looking at the responses, the request, and the throughput here. And what I'm trying to highlight here is that this is in a healthy state. So on the response time, that kind of line across, I think I zoom in here, is around 60 milliseconds. This one's running pretty healthy. And so those vertical bars are the volume. So this is the volume versus response time kind of view. So that's just kind of showing this function kind of that it's running okay. And so then what we're going to do next is to cause a problem in the application. And here's my JMeter script that I have running. And so it's sending in a series of requests just kind of continuously. And so the add function is the one I'm going to break, or the create Lambda function. So here, maybe this particular one was about 100 milliseconds. And so what I'm doing with this particular app, I'm able to pass in a payload that says, this is a slow, a slow element, and then the code logic will kind of invoke a slowdown on the code based on this payload that's coming in. So when I rerun my JMeter script, that's going to start sending some load again, and you can see now my latency is now up to 3 seconds. So what I basically did was slow it down from milliseconds to a couple seconds, which will really force a problem to be picked up on Dynatrace just for demo purposes. So there's another request. So now back on the Dynatrace side, so I've kind of sped up a little bit. But now if you notice the line is hovering around 2-3 seconds response time. So here we had sort of a baseline, and then boom, this one's really out of whack, which is what we wanted to do. So Dynatrace obviously would have picked this up, and we're going to drive into what the AI engine did as a result. So, and Dynatrace is not detecting a single metric violation and sending a bunch of alerts to tools. It actually is building what we call a problem card, which is constructing a window of time where there's some anomaly, and then as it gets more information, as it's interrogating the environment. This is kind of a very simple example, but the idea here is that this constructed card gives you business impact, number of applications impacted. So if this was a more distributed app that had many, many components, you could see that instead of being alerted and alarmed and all these different things, you can summarize it all in a nice card here, and then the AI engine, through kind of a causation engine, is looking at patterns and dependencies to come up with what it thinks the root cause is. So in this case, this is just going to be this Lambda function is the root cause of the slowdown, but we want to further analyze, okay, what about it is causing it to go slow? So this is what we're looking at here, and I think we're going to drill into the analysis of the slowdown. And so built into Dynatrace is a ton of, that's kind of a heart of what we do, is a lot of diagnostic tools to drill into the root cause. And we have a lot of pre-built analysis here. So right now, this one is constructed for slowdowns. Is it a queuing problem? Is it a database problem? Is it a code execution problem? So in this case, what the code was doing when it slowed down was actually calling a third-party site that's causing the slowdown. So the code's not slow, but it's the thing that this thing is in turn calling is the root cause of the slowdown. So what we can do is, like we did before, we'll kind of drill into, just for demo, into the individual invocations or the pure paths. So again, time series data, but we'll pick one of these ones that's slowed down here. You can see it's like 2 seconds. So as we drill into it, again, this individual call, we'll look at the pure path, we'll look at the timing, and it'll jump right out immediately that the root cause is, in this case, invocation, calls a third-party site, as you can see, and then it makes actually 2 RDS calls, which are pretty quick. So I think I flip back to the summary view, and then you can kind of see that. So here's my response time of a couple seconds, and I think I come back. And anyway, I guess it didn't come back. But anyway, so that call to third party is the root cause. So as a developer, you would know immediately that was the problem. And what we're trying to do is also in Dynatrace give this bigger picture of the service level of the app. So we want to not just look at the Lambda functions, but bubble this up into views and dashboards and service level management. So if something's violated, that we have that kind of visibility at the top level. And then when problems arise, the root cause engine gets us to the root cause, and then we can hopefully remediate any problems that come up rather quickly. So with that, I'm going to kind of turn back to Carmen, who's going to talk a little bit about the internals of how the Lambda layer is set up.
Yeah, thank you. Okay, so what you're seeing is essentially what it looked like before, right? So again, when you think about how does it work under the covers for you as a customer or you as a partner, think about it this way, right? You get an execution environment, call it a sandbox. It's an isolated space for you to run your workloads, right? And then what you have inside of that is essentially what's called the runtime API. And if you think about the most simplistic example, like typically, customers have SNS topics or SQS topics, some sort of event, maybe a file has arrived in an S3 bucket, whatever it may be. And then you, as a developer or an operator, figures out, like, I want to subscribe my Lambda function to that particular event. And as part of that event lifecycle, once you make that subscription, what happens is the Lambda service talks to the runtime API, and then it basically passes that event to your function handler in your code. And again, Lambda supporting popular languages like Java and Python and .NET, because I'm a .NET fanboy. But either way, all of the popular languages, it's handled the exact same way, where basically it's like, here's your event, pass it over the runtime API, and present it to your application code. You're then going to go do some work, and whatever it may be. Like maybe you're going going to do some processing on that image that arrived in that S3 bucket and then go push it downstream to something else. Or maybe you're going to process that application off the queue because maybe it's an order for your customers, whatever it may be. But the thing here is when you think about it and it's done, and when you pass the event back to the runtime API, there was a challenge, right? And the challenge was like, well, how do I do things like observability inside of there with a third-party solution? Like, where am I going to do that? And typically the way it was done is you would actually, take that third-party solutions library and you would pack that into your application code. And that's completely okay, but why not give a greater level of control? Because a good example is sometimes there's logs that need to be processed, and you want to actually do that after your function has fired down. You want to have control over the execution environment because sometimes you have a large set of logs that you need to send downstream. Maybe you're sending it to an S3 bucket. Maybe you're sending it to like an Elasticsearch or whatever it may be. But you need control around when to start that function up and then at the same time when to fire that function down and pause it. Because remember, Lambda basically takes your execution environment, and when you're done, it doesn't destroy it. It actually pauses it for the next invocation. And the very next time an event comes along, we call it essentially like it's a warm start. You're bringing that up and you're starting all over again. But the thing is, in the Lambda execution environment, the way it works today, with Lambda extensions, we've introduced this new concept, right? We have this concept of internal extensions, which run as part of the runtime process. So again, if you're writing like Python code, you would have an internal Python-based extension running in process with your code. But then we also have the concept of external extensions. So still in the same execution environment, but this gives you greater flexibility, right? This allows these third-party solutions to come in and integrate with the Lambda environment and, more importantly, your application code. Granted, they both work the same way where they have control over the lifecycle event of when to fire up and when to do things before your application code fires and when your application code is done. And they all share essentially the same concept of you have to think about like the overall amount of memory and CPU that you give to your Lambda function because it's sharing that space, right? When you're basically saying I want X CPU and I want X memory, that's part of the concept of Lambda extensions where, granted we give you this new layer, but it's all really combined under the covers in terms of consumption. And when it comes back to billing, again, you're paying for as long as your application code runs and also for as long as your extension runs in that combined manner. But the way that it works, under the deep covers is we've essentially introduced what we call the Lambda Extensions API. And to my point where I'm saying that you can control things before, after, and next, this is specifically where folks can write their own and or a partner will jump in and build that integration with that API to interact with the overall execution environment. And then on top of that, which is really, really cool, if you think about it, in the past, the way that customers and partners would essentially get their logs out of Lambda would be to basically emit them out of their application code, but at the same time, you have information about the Lambda execution itself, like when did it start, how long did it take, all of that information was being streamed to something like CloudWatch. And then you would have to go with a third-party tool, or you would have to, whatever technique you would use, you would have to kind of aggregate all of that together inside of something like CloudWatch. As part of this new extensions model, we introduced a logs API, and it's a perfect example of how a partner can jump in, plug in, and actually catch those logs real time and stream them out to their environment. So super powerful, super flexible for partners to adopt. And again, like really excited to have you guys on board because I know it helped in your case of pulling logs, visualization, and metrics. So,
right. So I think what I'm just gonna give you a little overview about how this gets set up, and then we'll have a demo where you can see it because it is easy, right? So I mean, prior to the Lambda layer, I mean, we had to do SDKs and adjust the code, and then it was invasive in different languages. So by leveraging our one agent technology, we have basically a lightweight extension that then supports multiple runtimes in the same way all of our other Dynatrace technology works. So as you can see on this screen, this is just within the Dynatrace platform where you're choosing how to deploy the one agent. So the Lambda layer, you can also see Kubernetes. This is sort of the same place where we kind of start our wizard to kind of have our setup scripts. But within Lambda, we want to support multiple, techniques of how people want to roll out this one agent and configure it. So the one I'm going to walk through for the slides is using a JSON kind of file approach where you could kind of cut and paste and put things within the AWS console directly. And then the video I'm going to show in a minute is going to be actually showing some of the environment variable options, just so you see. But you can see there's quite a few ways that you can do it depending on your environment. So here, this is just a screenshot of what the next page of the wizard looks like, where you can see, how to construct this JSON payload, and kind of part of that are some of the secrets and tokens that are related to that. So this information is put directly into the console, so you can, test this out. If you have a, Dynatrace environment, you get this set up. You just kind of take this, the ARN and the runtime that you want, get the token. You can kind of put it inside the Lambda layer area, right directly in the console. And then once you have that, you can see down here on the bottom, this is the specific layer library that you need, and that will show up in the AWS console on this kind of layers area over there. And then just by doing that, every invocation is then automatically going to show on the services page, which is the thing that I demoed earlier. And then you're now getting this distributed tracing, because it's going to now be part of some end-to-end call, and that's really all that's involved. And then so let's just show this little demo of how to set it up. And this setup here is going to be using the serverless framework. So we're going to take some of the environment variables out of the Dynatrace console. So here, this is letting you actually see the wizard in action. So when we're deploying Dynatrace, we can go into start the deploy. And then we're going to choose the option when it comes up here. We'll pick the AWS Lambda on the top right. And then we're going to choose the option from the drop-down that we want to do the environment variables. I actually zoom in. So we'll pick the configure with environment variables option. And then what that's going to present is basically the export statements with those values for, because each Dynatrace environment has an endpoint. We have an API where all the metrics are coming in. And then you're going to have an authorization token, which it needs to actually connect and push this information in. So Dynatrace runs on SaaS. Our SaaS infrastructure is actually run on AWS, as also customers can deploy the entire Dynatrace platform into the AWS accounts that they have as well. So flipping back to my code, this is actually the serverless framework. If you're not familiar with that, I think I highlight the serverless.com. And this is a way to basically automate the creation of the CloudFormation templates and all the resources, which you'll see in a second, that are required, from an API gateway to the individual functions and the roles. So here you can see this sample app also has a DynamoDB database, so that's also defined in here. So here you can see each function is kind of laid out in this config file. And so each function, the update, the create that I demoed earlier, is highlighted here. And so here you define the layer that you want and the version and the runtime. And then all those environment variables are put in this config file as well. So a more secure way obviously would be a secrets store, but in this case, they're just kind of put it there for the demo purposes. So when you run this deployment serverless framework, this is sort of the output, what it does, and it's saying, hey, I made all these particular functions. Here's their endpoints. Here's the functions it created. And then we'll flip over to the AWS console. And so the stacks that got made, there's a series of them because there's quite a few resources to kind of set up this particular demo app. So if I click on the Resources tab, you can see things ranging from the gateway itself to various roles to each individual Lambda function is there as well. So that's kind of why people use these various deployment frameworks, just so that everything's kind of managed as configuration. You can tear it down, recreate it, version it, et cetera, et cetera. So here, this is the listing of the console of each individual function. If you drill into a function, this is what the screen looks like. So you can see the function is sort of sitting behind this API gateway. This is the code itself that got deployed as part of that framework. And then within the configuration, those environment variables for this deployment approach are viewed here. And then if we go back to kind of the main console, scroll to the bottom, there's the Lambda layer. So you're not limited. I mean, you can tell me more, Carmen, but it's designed to support more than one-to-many layers, so you're not limited to one.
10 layers.
10 layers, there you go. So, and that could be things from a security agent to code metric agents. There's a lot of different ways. So back on the Dynatrace side, just to kind of, now you've seen this, you should be familiar with this. This is our view, another way of looking at the AWS account and then kind of drilling into each function. So ones with the blue highlight, I have the layer enabled. And then this is the same view that you saw before. So now that's basically how the deployment and the setup works. And then what I think I'm going to show, I think that might be the end of this demo. And then let's give it a second more. And then I'm going to go into just a little more details about some of the analysis that you can do. So let me just click next. All right, so We talked a bit about this before, but just kind of to recap kind of what we've seen a bit. But with the agent in place, we're getting each individual invocation, we're getting the call stack, we're seeing the code that's being executed, and then all this is feeding into our AI engine, as well as kind of diagnostics for developers to see what's going on. This cold start analysis is an option, but it's not limited to just this. You could be looking at just behavior of different functions. If you're looking at, I've switched over from x86 to an ARM architecture with Graviton. This is what kind of Carmen mentioned before, being able to look at the baseline and the benchmark for those types of changes. This is the cold start example. But then within optimizing diagnostics, there's a lot of built-in features of Dynatrace, from the hotspot analysis of the code to comparing windows of time, analyzing threads. I mean, there's a lot of capabilities that you can do here. And then this hotspot analysis is really letting me see, where time is being spent at an aggregate level. And then I can compare timeframes, is something that I just mentioned. And then, and really at the end, what we're trying to do is really get the benefits of AWS, which Carmen can maybe summarize, and then combine with Dynatrace.
Yeah.
Which is why we're partners.
Yeah, exactly. So I think the thing that hopefully you took away from this session is monitoring your environment is a hard problem, right? So as you scale, as you basically build net new, as you migrate, you really want to think about the observability challenges, and essentially how can you pinpoint exactly where problems lie when they happen, and more importantly, how can you fine-tune your workloads to figure out where to optimize for cost. When you think about the serverless model, absolutely, you want to spend your time working on your applications. Why are you going to figure out managing servers and patching infrastructure? We talk about that flywheel, that's essentially a wasted portion of time inside of that flywheel. Your development teams and your operations teams should be focusing on more value-added activities within your enterprise, thinking about how to fine-tune, how to figure out optimal deployment patterns, and how to basically figure out, when am I going to, maybe break off this next new component because I see an opportunity to fine-tune this even further, right? Let them figure out how to strategize to make the application better and figure out how to cost optimize at the same time. You guys have been super, super helpful. It's been a great partnership over the years, working together. It's not just in the container space. It's not just in the serverless space. I've been with the Dynatrace folks since my time, in the beginning time here at AWS, going all the way back to the mass migration days, and it's been a great partnership across the board. So
yeah, well, thank you for that. Yeah, I mean, you've covered a lot, but I think as you're transforming, you do want speed and scale, but it is introducing complexity, and I think that's really where we're combining the best of what we do, the best of the compute resources, and to drive to that modernization goal. Yep. And so I think we're going to, for those that might be watching the video afterwards, we put a couple QR codes to some additional kind of follow-up resources that you guys can check out.
Yeah, and for the folks that are here, I know today's Thursday. I believe there's a workshop. It's not necessarily geared around Lambda extensions, but if you're excited in the serverless space, check out and see if the Innovator Island workshop is still running. If not, that's a great resource to learn more about serverless. You can do that offline. There's an amazing video up on the YouTube led by one of our DAs, James Beswick, around basically building event-driven architectures and how to take advantage of things like Lambda and EventBridge and all of the cool toys essentially that folks want to build with. Yep. These blogs are very specific to today's talk, but there's a wealth of resources out there, and hopefully you folks are diving deep this week, and if not, we all know that the content will be up online, and the AWS team's more than willing to help after the fact. You just got to ask. So.
Right. Yeah, and I guess another shout out for if you're going back to the expo floor before they close. As soon as you walk in the main entrance, to the left is the big Dynatrace area. So we've got over 40 people here that could answer more questions, demo some of the things I was showing you today, talk about some of the other AWS services that we support. So yeah, please come by and thank you for this time to talk to you guys.
The last thing I'll say before closing, again, thank you for your time. Please fill out the speaker score sessions in the event app, not just for this one, for all the sessions that you've gone to today. This is, I think, my 7th reInvent as an AWS speaker. We take that feedback very seriously. So everything that you can give us to make the event better for you as an attendee, just take a couple seconds to put that information in the app, and we'll definitely take a look at it. I know I do. So with that said, thank you very much for the time, and thank you, Dynatrace, for having me.
Thank you,
really
Carmen.
appreciate
Thank
it.
you, AWS. Yeah,
Awesome. Thanks, folks.
Right.